Okay, let's start. So we were discussing examples. Let me give you a few more examples. So far the examples have been pretty easy, bordering on trivial. So the next example is not so trivial. So this is a group which is defined in terms of matrices. So this group is called GLNR. And it consists of the set of all n by n matrices with real entries and non-zero determinant, okay? And the group multiplication is matrix multiplication. Okay? So let's prove this, okay? So do you understand what we are talking about? We are talking about matrices of the form, say, M11, M12 dot dot, M1n, M21 dot dot dot, N1 dot dot dot, MNN. Okay, where all the M's are real numbers, with the constraint that the determinant of M is not zero. Okay, so all these set of matrices form a group. Okay, so let's prove this. Okay, number one is closure, right? So you want to prove closure. So suppose that M1 and M2 are both in GL and R. So then let's consider M3, which is M1 times M2, right? This is the matrix multiplication. So now, what is the dimensionality of M3?
So n by n.
Right, so it's n by n, so M3 is n by n. What are the entries? Are they real numbers or not?
Yes, real numbers.
Real numbers. Now the more interesting one is, what about its determinant? So the determinant of M3 can be written as the determinant of M1 times the determinant of M2, right? And since this is non-zero, this is non-zero, the determinant of M3 is also non-zero, right? So we see that the closure property is satisfied. Now, identity is just I, right? The identity element is also in GLNR, right? So this is the identity element. So we have identified the n by n identity matrix as the identity element of the group, right? So this is identification, not equal. We've identified that to be E. Number C is its matrix multiplication is associative. So the associativity is also satisfied. And number D is that if M1 is in GL and R, And since the determinant of M1 is non-zero, that means that the inverse matrix exists, right? And it's unique. So we can say that the inverse matrix is the M1 inverse is the inverse of M1. Okay. So we have shown that this is a group, right? Any questions? Okay, so let's make some comments. Number one is G, L, and R is non-abelian, right? Because matrix multiplication is non-abelian. Number two is that what is the dimension of the parameter space? What is the parameter space of this matrix, of this group? Can someone try to guess? How many real numbers do we need to specify?
Square.
25.
25?
Sorry, n square.
N squared, right. So the parameter space, would it be Rn squared?
R in square
sir.
contains
R-
the
course.
ones with determinant 0. So we need to exclude those ones.
Yes.
R minus all those matrices, all those points in Rn squared, such that the matrix that we can make out of X, if this is 0, we exclude those points, right? Is that what you meant, Otonu?
Yeah.
Yeah, okay. So this is going to be the parameter space. And by the way, this the dimension. So this is an example. This is an example of a continuous group, which is also known as a Lie group. And I'll introduce the concept later formally, but the the dimension of the parameter space is called the dimension of the group. Okay, dimension of the group. Because what is the number of elements of this group?
Uncountably infinite.
Right, so it's uncountably infinite. Therefore, the number, so the idea of a dimension is a more useful notion. So for countably finite groups, the number of elements is what we call the order of the group. Okay, so I'll introduce that concept more formally in the next class. But yeah, anyway. Okay, so is it clear why GL and R is a group? This is very important. All the matrix groups that we will be studying will be subgroups of this. Okay, so exercise is, now show that GLNC, where C are, these are the n by n matrices with complex entries and non-zero determinant, form a group. And also show that GLNR is a subgroup. Okay. Is a subgroup of GL and C. As you can see, these are very easy exercises, but I'm making you do this anyway. Because from experience, I know some of you will not be able to do this, even though your brain will freeze up because you haven't practiced, okay?